Hello everyone. In the last class, we spoke about what reactions were, what chemical equations were, and how to balance chemical equations. In this part of the chapter, we will speak about types of reactions. Alright? So there are several types of chemical reactions. Depending on what is happening at the molecules, you can classify them into a few types. The first one is called a combination reaction. The name says it all. Many reactants combine to form a single product. Now, to give you a good example of this, consider calcium oxide in water, CaO, in water liquid will give you CaOH twice. Now this reaction is already balanced, okay? Calcium oxide is also called quicklime, and calcium hydroxide is called slaked lime. Just common names that you can keep in mind. Now, another thing that you can see in this reaction is you get heat. So this is an exothermic reaction. Exothermic reactions are those where heat is produced. Alright? So if you want to see how this actually works, I recommend you check out the first link in the description below that speaks about calcium oxide in water. Alright? Now, is this the only kind of combination reaction? No. Think about carbon burning in air to give you CO2. Now, this is also an exothermic reaction, and this is the reaction that is used to produce electricity in coal-fired power plants. So if you take carbon in the form of coal, you get carbon dioxide and heat. Now, burning of coal is how you produce electricity. The heat from an exothermic reaction like this is used to heat water to make it into steam, and that steam is used to turn turbines, which can then make electricity. So a lot of the electricity we use today come from coal, which is an exothermic reaction. All right? A very similar exothermic reaction is burning of hydrogen. H2 plus half O2 gives H2O, water, plus heat, let's not forget. So it does burn. Basically, you have two or more reagents that combine to give you a single product. The same here, you have two or more, you get one single molecule out. So these are combination reactions, okay? Now, let's look at the exact opposite of this process. So that would be called a decomposition reaction. So think about the meaning of the word decomposition. You have a large complicated molecule which you can break into several smaller, less complicated molecules. So here, one large molecule breaks into many smaller molecules. So what could be an example for this? A simple example, an experiment all of us can do, would be the breakdown of iron sulfate, iron 2 sulfate to be specific. If you heat iron sulfate, you get iron oxide, Fe2O3, plus SO2 plus SO3. Now both these are gases. Alright? Now how do you balance this reaction? We have two sulfurs, only one here, put a 2 there. Oxygen, we have 4 2s 8, 3 plus 2 plus 3 is 8. 2 ions, so this is balanced. So what does this mean? Here you have one reactant, you have 1, 2, 3 products. So iron sulfate is breaking into 3 products. Alright? If you want to see how this works or where, you can look out for our link 2 in the description, which is the decomposition of iron sulfate. Okay, it's a simple reaction. Now, is this the only kind of decomposition reaction? No. There is another one which you can see in link 3, PbNO3 twice, which is lead nitrate decomposition. So what happens then? If you take lead nitrate and you heat it, you get lead oxide, oxygen, and nitrogen dioxide. How does that happen? PbNO3 twice. When you heat, you get 2 PbO plus 4 NO2 plus O2. Now these two are gases, and this is your balanced equation. This is, let me write the names of the compound just so that you know. This is lead oxide, lead nitrate, nitrogen dioxide, and oxygen. Now these two are gases. This is a reddish brown colored gas, and you can see this very well in the video, so I recommend you go check it out. So these are decomposition reactions, both of which undergo heating, right? Only when you heat these do decomposition reactions undergo. Now look at combination. In a combination reaction, you get heat, right? They are exothermic reactions. Heat is generated. But decomposition reaction, you have to provide heat because you are taking a molecule that's already there and you're trying to break it. So you have to give it energy. Now note that I say energy and not heat. That is because you can also cause decomposition through electricity. Decomposition by electrolysis. A classic example for this is breaking of water. Water can break with electricity to give you hydrogen plus oxygen. Now how do you do this? All you need to do is connect the battery and 2 electrodes to water, and then a mechanism to collect the gases that are produced at each electrode. How would you do it? You have that in a very good video in link 4 in the description below. So you can break a bond, you can break a molecule using electricity as well. Not only that, you also have decomposition reactions by the action of light. And this was very important because in the past it was used for photography. Alright? So you might have seen old black and white photos. They were made using a photochemical process. Alright? The example for that is AgCl in the presence of light would give you Ag plus Cl2. So to balance this, chlorine escapes as a gas, the silver sits as a solid. So this is where you get the photograph. If you expose a part to light, then that part silver settles. So that's why you have a negative, and then when you pass light through it, you get a positive image. Alright? Now, not only chloride, even silver bromide can undergo this reaction. You get the same, but bromine gas instead. All right. So these are called photochemical decompositions. Photochemical decomposition. All right. So decomposition, you require energy. It could be in the form of heat, in which case it will be called thermal decomposition. Otherwise, it will be electrochemical or photochemical. All right, so we spoke about decomposition reactions as well. Now, what other kind of reaction do we have? We can speak about a displacement reaction. So the name says it all. Displacement is where one element moves another element out. Okay? So say you have two compounds or one compound and an element. Say iron and copper sulfate in solution. You drop a piece of iron into copper sulfate solution. You get copper out as a precipitate and iron sulfate. Now, how do you see this? This is very easy to notice. Iron is a silver gray metal. Copper is a red metal. And copper sulfate is blue in color. Iron sulfate is green in color. So this is an experiment that you can do. Just drop a piece of iron into a copper sulfate solution and you can see this color change. Now, if you actually want to watch it, you can. The link 6 in the description below will give you the above reaction. You can take a look. It's very well done. So here you can see iron is knocking copper out of copper sulfate. So copper comes out and iron sulfate is formed. So iron is displacing copper from copper sulfate. Please note, it is not just iron. Any metal that is more reactive than copper can cause a displacement reaction. It is not just iron. So what could those metals be? Those that come higher up on the reactivity series, which you will be studying in a later lecture. All right. So this is a very simple example for a displacement reaction. You can also do the same with zinc, lead, and so on. It just has to be more reactive. All right. Now, we spoke about displacement. There is another kind of reaction very similar to this called the double displacement reaction. I'm pretty sure most of you would have guessed by now. Double displacement is where you have two different solutions with two different sets of ions that replace each other. A classic example for this is sodium sulfate mixed with barium chloride. Now both these are very soluble and they're clear colorless solutions. But the second you mix them, you don't even have to heat, you don't have to do anything. The second you mix them, you get a white precipitate of barium sulfate and then sodium chloride remains in solution. All right. So this is a white colored precipitate. This is a white precipitate. This remains in solution. These have always remained in solution. So here, two displacement reactions are happening. First, sodium is displacing barium from barium chloride to give sodium chloride, and barium is displacing sodium from sodium sulfate to give barium sulfate. So you have two independent displacement reactions going on. So it is a double displacement reaction. This you can look at link 7 in the description below. All right. So now we have seen 4 different kinds of reactions. The last one you want to look at is called the redox reaction. which is a short form for reduction and oxidation reaction. All right. So before we go into what this is, you first have to understand what reduction and oxidation are. All right. So let me write up a note here. Earlier, we used to say reduction is loss of oxygen and oxidation is gain of oxygen. But today, we say reduction is gain of electrons and oxidation is loss of electrons. Now, how do you measure that? Think about it this way. Look at the charge of an element. All right. Let's say we have FeO plus O2 gives Fe2O3. All right. So how does this happen? Well, look at the charge over here. Oxygen is always 2 minus, so iron is 2 plus here. But over here, iron is 3 plus. So what has happened is iron has lost 1 electron. Now if a single electron is lost, loss of electron is oxidation. So this is an oxidation reaction. All right. Now what about a reduction reaction? Let's think about FeO plus C gives Fe plus CO. It's a simple enough reaction. FeO is again plus 2, but Fe by itself is 0. It is not charged. So here iron is gaining 2 electrons. And we know that gain of electrons is called reduction. So please look for the charge in the atom to give you what is going on. All right. So let's look at another part over here. What about carbon in this reaction? Carbon is 0 here, but here it is minus 2. So carbon is undergoing oxidation. All right. Okay, carbon is plus 2 here because oxygen is minus 2. It is losing 2 electrons. So in the same reaction, you have iron undergoing reduction. You have carbon undergoing oxidation. So in one reaction, both oxidation and reduction happen. So that is why these reactions are called redox reactions. All right. Another good example for this would be copper. Something you can do again. Cu plus O2 gives CuO. Let's balance this, I guess. Yeah. So let us look at the number of electrons that copper has. In the over here, copper is not charged, so it is 0. What about here? Oxygen is 2 minus, so copper has to be 2 plus. So what is happening here? Copper is undergoing oxidation because it is losing electrons. This is an oxidation reaction. How do you do this? It's very simple. Look up video number 8. The 8th link in this description. You can heat copper in air. Just heat it to give you copper oxide. Copper oxide is black. Copper 2 oxide is black. Copper 1 oxide is still pink. But yes, copper 2 oxide is a nice shade of black. How do you reverse this? Very simple. You take CuO and heat it with hydrogen. You get water plus Cu, metal. So again, you can see that copper here is coming out, and this copper is going from +2 to 0 state. So that is gaining of electrons. This is reduction. And at the same time, hydrogen is losing electrons because from H0, H is becoming +1 each. So this is oxidation. So hydrogen is undergoing oxidation, copper is undergoing reduction. So this is also a redox reaction. All right. Now we are speaking about, let me just give you another example where we don't deal with oxygen at all, so that you get the concept. Let's look at MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Now we know that oxygen is 2 minus, so Mn here is 4 plus, whereas chlorine is 1 minus, so Mn here is 2 plus. So Mn is gaining 2 electrons. And gain of electrons, as we know, is reduction. All right. So this is how you are supposed to look at reduction when oxygen is not involved at all. All right. So now that you know those definitions, we are still speaking about oxidation. There are two common examples of oxidation that we see in everyday life. All right. Think about it. Oxidation in everyday life. What happens if you leave a piece of metal open for too long? Think about iron. If you keep iron open for too long, it rusts. So that is because of oxidation. Oxygen in the air with water can combine with iron to give you rust, which is an oxide of iron. So we can say the loss of metal surface under oxidation is called corrosion. Please note, it is not only iron that can corrode. Even other metals like copper and silver corrode, but we call them tarnish. Copper turns green, silver turns black, iron turns brown. These are all corrosion. The surface is what is affected. All right. Now, another thing that I'm pretty sure you've noticed is when you keep a fat or oil containing food outside for a long time, you will know it has a bad smell, right? That is called rancidity. So what is rancidity? The bad smell observed on food products with oil or fat caused by oxidation. All right. So you might have noticed that when you buy a packet of chips, say Lay's or something, it comes with a lot of gas in the packet. Now that gas is nitrogen, because if you fill it with air, there is oxygen and rancidity can happen. So preventing rancidity is done by removing oxygen from the environment, from the immediate environment of your food. So that is why your Lay's has all that air. Okay. So if you want to know more about corrosion, you can look up link 9 in the description below. It's a good overview of corrosion, rusting. With that, we complete this chapter. If you have any questions or doubts, please leave them in the comments below. I will be uploading a version of this and a more comprehensive notes on a dedicated website soon. You can access it over there. So thank you very much. I will see you at the next lesson.